Okay, chemistry revision with Mr. Rankin. Eat, sleep, revise, repeat. We're going to look at C1, so let's choose a pen. In fact, if we look at the paper, we're going to do this one. So, okay, so this is the higher tier. It's chemistry C1. If I go quite quick, don't worry, you can just re-watch it if you want to. Okay, remember you've got an hour to do these tests, so C1 will take you an hour. Okay, let's move on. Just choose a red pen and describe a test to show that the gas is chlorine. Right, well, chlorine, if we take damp blue litmus paper and it is bleached white. Okay, you might put after turning red, so that's 1 mark and 2 mark for bleaching red. For bleaching, sorry. So the chlorine does turn blue litmus paper red because it shows it's acidic, and then it gets bleached. But the mark scheme just wants you to know litmus paper and that it bleaches white. So there we go, 2 marks. Right, we're off. State with a reason, a safety precaution. Okay, talk about ventilation, opening a window, because what we're talking about is chlorine gas. Because it is toxic, you don't want to breathe it in. 2 marks again. Ka-ching. Complete the sentence by putting a cross in the box. Right, we're talking about chlorine to make one of these. So the only one is polyvinyl chloride, which has got chlorine in it. So that's the one that we want. Okay. Next, we're on to still on question 1. Okay, B. We're looking at the pie chart. Gas A is nitrogen, and if we take 21 and 1, gives us 22, so that leaves 78% nitrogen. Stick that answer in there because that was the name of the gas. Okay, nitrogen. That's the most abundant gas in the atmosphere. One reason why this has happened. Carbon dioxide. Okay, it's from burning, isn't it? So combustion is the word for burning of fossil fuels. Okay. And I think we're moving on to question 2. Question 2. How is calcium carbonate turned into calcium oxide? So that's that bit there. Simply heat it. Okay. That's 1 mark. One observation that can be made when water is added. Okay, we're going to see steam when you add it to the hot limestone that's been heated. So you might see the limestone flaking as well. Steam, you may hear hissing as well. The mass of calcium hydroxide solution is measured. Okay, so 1 gram of that and 100 grams of that, the products are going to be 101 grams. That's because of conservation of mass. No atoms are lost, destroyed, created. It's always going to be the same on both sides. Okay. Yep. Let's move on. So, still on question 2. So let's move on. Just move that along. Okay, right, so we've got, this is the metal carbonate. It's heated with a Bunsen burner just there, okay, and it's going to give off bubbles of carbon dioxide gas, so the lime water in there should turn milky. Let's have a look and compare these 4 carbonates. Okay, so the time for the lime water to go milky, that was 57 seconds. That one must be the second most stable because that took over 300, so that's the most stable carbonate there. So which one of these, why did the lime water go milky in some of these experiments? Must be carbon dioxide is formed from the metal carbonates. Yep, so any carbonate gives off carbon dioxide when it's heated. Now, what do they show about these metal carbonates? Well, it's just as I described up here. So you need to say in there, the most stable would be barium carbonate, because it took over 300 seconds. We've got 1 mark up there. We want 2 marks here. So say about which one is the most stable. Okay, that'll give you 1 mark, and why you know that is because it took the longest to decompose. Okay, let's move on, and we're on question 2 still. Why scientists would repeat the experiment? Okay, so to get a more accurate result. Okay, so we take averages and get an accurate, that's 1 mark. We'll get an accurate result. Why else would they repeat it? Okay, so to reduce anomalies. Okay, reduce anomalies. Sorry. Okay, so that's the end of question 2. We'll move on to question 3. This is metals now. Topic 3, metals. No, topic 4, isn't it, metals? So, iron and steel. What is meant by the term ore? It's the rock. So the term ore is the rock where we get the metal from. Okay. The next one, stainless steel, is to give it resistance to corrosion. So stainless steel is an alloy. Okay, it's a mixture of one or more metals, and it's to give it greater resistance to corrosion, i.e. stainless. Knives and forks. Okay, fantastic. Why is it important to recycle scrap steel? Okay, so less energy, one mark, and natural resources required. So natural resources would get you the other mark. Okay, still with question 3. Okay, how does the equation show that iron oxide is reduced? So the iron oxide, Fe2O3, goes to iron, so it's lost its oxygen. So it's lost oxygen. If something gained oxygen, that'd be oxidation. Okay, the metal depends on the reactivity of the metals. The method used to extract depends on the reactivity. Okay, so iron and aluminium are extracted by 2 different methods. Okay, so first of all, iron is less reactive than aluminium. 1 mark there. We're looking for 4 marks though. Iron is less reactive than aluminium. So, the oxide, so iron oxide, can be reduced by heating with carbon. Okay, so it will be reduced by so the iron oxide will be reduced to iron. So that's 2 marks. Okay, aluminium is more reactive and is extracted by electrolysis. Okay, is extracted by electrolysis. So just let me check the mark scheme on this one. What's the 4th mark for? So what are we on question? We're still on question 3, part D. That's it. That's the whole thing. So iron is extracted by heating with carbon. Got that. Iron is less reactive than carbon. By heating with carbon. Yes, got that. Aluminium extracted by electrolysis. Got that. Well, it's because aluminium is more reactive than carbon, but we've sort of said that earlier on, didn't we? So, because aluminium is more, no we didn't, is more reactive than carbon. So what that means is, on the reactivity scale, if you remember, I don't know, please send Charlie's monkeys and zebras in lead cages securely guarded, we would have iron, which would be there, symbol Fe, aluminium there. Okay, carbon would be in between them. So carbon can reduce iron. Okay, iron oxide to get your iron, but it couldn't reduce aluminium oxide to get aluminium. So we need electricity for these ones up here. Okay, so that's electricity, which we call that electrolysis, a chemical reaction caused by electricity. Okay, tough question that. Bit of revision on electrolysis there for Mr. Rankin. Okay, acids and calcium carbonate. So describe how sedimentary rock is formed. So we're looking for 2 marks. We want to say how a sedimentary rock is formed. Okay, so layers or sediments are compressed. That will get you a mark. Over a long time, over millions of years. Okay, for the 2nd mark. Okay, now we're flying. How's rainwater damage the statue? Well, the statue's, I think it says it's limestone, probably in the question, calcium carbonate. So rainwater is, it's all slightly acidic. That'll get you 1 mark. Therefore, it has reacted with the limestone or the calcium carbonate. Okay, right, next one. So we're still on question 4, but calcium carbonate is added to acidic soils. Well, what sort of reaction is that? Well, it's neutralization. Okay, so we're talking about an acid and an alkali. Okay, or acid and base is neutralization. Okay, 3 of these are made of calcium carbonate. So limestone is calcium carbonate. Marble is a metamorphic rock, which means it's changed from limestone into that, but it's still the same formula, still calcium carbonate. And chalk is another form of calcium carbonate. So the one that's not calcium carbonate is quicklime. We get that from heating and removing the carbon dioxide from limestone. So explain why waste gases from the power station, why do they have calcium carbonate passed through them? Okay, so calcium carbonate is a base, or you can say alkali, therefore, so that's 1 mark, it neutralizes the acidic gases. So a bit like putting it on the field, the acidic field, we're talking about the acidic gases coming from a power station. Hydrochloric acid reacts with calcium carbonate. Balanced symbol equation. Okay, if it says balanced equation, it's not a word equation, this is where we're looking for symbols. Okay, balanced equation. So hydrochloric acid, you need to know that it's HCl. Calcium carbonate, it may have told you in the question above, I think, CaCO3. And it makes, so there's the arrow, okay, makes calcium chloride, and, well, it's a carbonate, so I know we're going to get CO2. We've got the salt there, that's made from calcium and chlorine, so calcium chloride. What's going to be left? H and oxygens, so we're going to get water. Okay, so what that tells us is that, I'm just going to change the colour of my pen there, is that an acid and base makes salt plus water plus carbon dioxide, because it's a carbonate. The base is a carbonate. Okay, acid and base makes salt plus water. Right, we're looking for 3 marks. Okay, 1 mark for the formulas on the left, 1 mark for the formula on the right, the products, and we just need to balance it to get that final mark. Okay, H's on the left are 1, but there's 2 on the right, so we need a 2 there. Okay, chlorines on the left are now 2, and we've got 2 there, so that's okay. Calcium's 1, calcium 1, carbon 1, carbon 1, oxygen's 3, oxygen's 3. Okay, so that's balanced. We get the 3rd mark there. Okay, right. Now, probably moving on to another question. Question 5, biofuels. The word equation for this, right, word equation, don't put symbols. Ethanol, okay. Now, for complete combustion, we know that we're going to get carbon, don't be tempted to put the symbols, CO2, carbon dioxide plus water, so that's combustion. Ethanol plus oxygen, of course. So the key is complete combustion means we get carbon dioxide, complete combustion. Okay, so again, easy to remember hopefully. Fuel plus oxygen makes carbon dioxide plus water. Okay, ethanol is used as a biofuel and it's produced by fermentation. So think about plants. Fermentation is where sugar turns to alcohol. Okay, so there we get our ethanol, our bio, which is a kind of biofuel. Okay, easy enough so far. Let's carry on with question 5. We're going to get to a 6-mark question, and here it is. Right, 6-mark question. If it's well communicated, that asterisk means that we'll get that 6 mark. If there's very little mistakes in your punctuation and grammar. So biofuels are made from plants, sugarcane to sugar beet. Petrol is a fossil fuel that is made from crude oil. Small number of filling stations sell biofuels. Sorry, the light's gone off on me here. Turn that back on. Okay, they sell biofuels. Evaluate the advantages and disadvantages of biofuels instead of petrol. Right, okay, so I'm just going to start with petrol because I know more about petrol. Petrol releases carbon dioxide, which is a greenhouse gas and causes global warming. But I've just remembered, but so does or so do biofuels. Okay, but biofuels take in CO2 when the plants grow. Okay, so that's going to get you something there. Let's just go. So advantages, disadvantages. Let's have a look. What else have we got? Yep. So those biofuels can be considered to be CO2 neutral because they take in CO2 even though they give out CO2 when you burn them. So if you talk about them being environmentally friendly, that's one phrase we want to get in there. But biofuels take up land which could be used for crops. And okay, let me just mark that up to there using the mark scheme. So let me add one thing before I mark it. I'm going to just add it here. I'm just going to put a little comma, but they are renewable. So obviously they're renewable because you can grow crops again in a year. You can't do that with fossil fuels such as petrol. You can't just grow that in a year. It's a fossil fuel, comes from crude oil, takes millions of years. So you might want to mention that as well. Let's just see how many marks this would get. So so for mentioning that they release CO2, there's 1 mark. For mentioning that it's carbon, can be classed as carbon neutral. So where did we put that? Cause global warming. Yeah, because they're carbon neutral, you might want to just mention that in there. But it will reduce global warming. There's less global warming with the carbon neutral biofuels. The land is another mark for saying that they take up land. For saying the renewable is another mark, that's 4 marks. And yeah, for saying petrol gives the greenhouse effect, that's there on the mark scheme. Okay, but biofuels, so biofuels have low availability, so they're not everywhere. Availability. Therefore, low impact. So you can't get hold of them. We can't take advantage of them. So I get you the 5th mark. And if you've clearly communicated it, maybe a bit better than I have, that's 6 marks. Okay, good luck there. Okay, let's move on to the final question, which is question 6. And no, it's not. Question 5. Hydrogen fuel cell is an alternative source of power for a car. Why there is an environmental benefit to using hydrogen fuel cells. Right, we're looking for 3 marks. They only emit water, because in a hydrogen fuel cell you've got hydrogen plus oxygen will give you water. So that's 1 mark. Advantages of, okay, so there's no carbon dioxide released, which contributes to the global warming or the greenhouse effect. Never mention ozone, by the way, on these exams. There's nothing about ozone in these. Don't get mixed up with that. Carbon dioxide causes the greenhouse effect because it's a greenhouse gas and it traps the sun's radiation in the earth. So that's the 2nd mark. Just double check the mark scheme for this one. Yep, so yeah, petrol producing carbon dioxide is the 3rd mark, so that's how we get 3 marks for that one. Probably on to question 6 now. Yes, okay. A little bit of hydrocarbons. These molecules are hydrocarbons, but explain which of the compounds in the table are hydrocarbons. Okay, so it's A and C because, looking at this one, B has oxygen. Okay, so if they are hydrocarbons, then they only contain hydrogen and carbon. Okay, right. Give the molecular formula of B. Right, so we're looking at this one here. Now it's got 3 carbons. It's got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens and an oxygen. Okay. Now it wants the molecular formula. So C3H8O. Okay. So you could give the structural formula, which would be C3H7OH, which is exactly the same. They're the same answers, only I've put the OH there because you see the OH is bonded separately on the end there. But both add up to the same. There's 8 hydrogens in both of those. What would you see if C was bubbled into some bromine water? Okay, so C has a double bond. There's the carbon-carbon double bond. So it will react with bromine water. Bromine is orange and it will go colourless when it reacts with an alkene. So it was an alkene because it had a double bond. Like here it's asking me to draw the structure of ethene, so double bond. Put my hydrogens on the end, and not time for a quick tutorial really. Let's just crack on. There we go. And last little question. Oh, a 6 marker. 10% of your exam. There's difference between a grade and not a grade. So evaluate these 3 methods of dealing with waste polymers: recycling, burning and burying. Okay, so I'll start with recycling, burning and then burying. Okay, so recycling saves energy and resources, 2 marks, and burning releases toxic gases, 1 mark. Burying, let's just have a look. Some plastics do not biodegrade. Okay, so they could be left there for a long time. You might just want to add to that. And if we just think about recycling up here, so okay, recycling, let's think, what does recycling, what are the problems? Okay, some plastics cannot be recycled. So some plastics cannot be recycled, and also somebody has to sort them, so they've got to be sorted. So another mark there for saying some can't be recycled. We've got that mark there, and that mark, and that mark. That's 4. That'll be 5. That's possibly 6. So there's quite a few things you could include there. Don't forget spelling, punctuation, and grammar. Okay, just make a clear answer if you can. Maybe you know, jot down your ideas on the back of the paper and then put it really neatly here. Okay, so I've been Mr. Rankin. This has been my revision session. Eat, sleep, revise, repeat. Don't forget the test is 1 hour usually, and take your time. Okay, let's go.